Hi guys, today I will solve one of the exercises that you did as a homework for you to know how to do it in case that you didn't, or in case that you have doubts. You can actually verify what I did and how I did. Okay, so we have this first exercise, which is a 22 kilogram mass is attached to a vertical elastic cord that is located 10 meters above the floor. The elastic cord has a spring constant of 190 Newton per meter. The cord's unstretched length is 300 centimeters. After the mass was attached to its end, the cord ended up with a length of 380 centimeters. At what distance is the mass located from the floor after it was attached to the cord? Calculate the gravitational potential energy. What is the stretch distance of the cord? Calculate elastic potential energy and the total potential energy. Okay, first of all, they're asking us to calculate height. Okay, so remember, we have a mass attached to a vertical elastic cord located 10 meters above the floor. So I'm going to do a sketch. So I have my elastic cord that initially measures 300 centimeters. Okay, then what happens is that they attach the mass, and now my cord is stretched. This is what happened finally. Why? Because I have a mass that is attached to the end here. Now, this cord is located at a distance of 10 meters. What is my height? My height, h, it's going to be the distance between my reference point, that in this case is the floor, and my mass. Okay, this is height. Now, how much the cord stretched? 380 centimeters. Okay, so this is what I have. How do I calculate height? Easily. Okay guys, here when you do the conversions, 300 centimeters will give you 3 meters. Okay, also 380 centimeters will give you 3.8 meters. If you don't trust me, do your own conversion and you will see it. Now, in part A, they are asking you to calculate height. So as you can see in the sketch, height is the distance from the floor to my mass. And my mass stretched the cord from 300 to 380 centimeters. Okay, so what is height? Height is going to be equal to 10 meters. That is the total distance from the floor and the place where the cord is located, and I will subtract it from my stretched cord. Okay, minus my stretched cord. This is equal to 10 meters minus 3.8 meters. This gives me 6.2 meters. This is my first answer. Now, in part B, they are asking me to calculate PEG. Okay, PEG equals mass times gravity times height. Now, my mass, you know, it's 22 kilograms. Gravity 9.81 meter over second square, and height, what I just got, 6.2 meters. When you perform this in your calculator, you'll get 22 times 9.81 times 6.2, 1338.08. As we are talking about gravitational potential energy, remember energy is measured in joules. And voila, we have our second answer. Now in part C, they are asking us what is the stretch distance of the cord. Okay, so how can we calculate x? As you can see, the cord was stretched from 300 to 380 centimeters. So to calculate x, which is the stretch distance, is stretch cord minus original. That's how you can calculate it, okay? So your stretch cord, that is 3.8 meters, minus the original, where that it was 300 or 3 meters. X gives me 0.8 meters. And voila, we have the third answer. Now in part D, it says calculate the PE elastic. Remember, PE elastic is 0.5. Nope. Okay. 0.5 K, which is the spring constant, and X, which is the stretch distance to the second power. So we have 0.5, 190 Newton over meter, 0.8 meters to the second power. Perform this in your calculator. 0.5 times 190 times 0.8 to the second power, 60.8 joules. And voila, this is it for part D. Now in the last part, it says calculate the PE total, the potential energy total, which is nothing more than adding gravitational plus elastic. PEG plus PE elastic. So this is 1338.08 joules plus 60.8 joules (1,398.88 joules), and voila. This is it, and this is basically the same way that you can actually do that second exercise. So I encourage you that if you didn't get this answer, do your own corrections, and in the second exercise, based on this exercise, you can do also your own corrections. See ya.